This is for the higher tier. Strong versus weak acids. Most students mix up strong and concentrated, but they're different. Strength is about how much an acid ionizes in water, whereas concentration is how much acid you started with. A strong acid, hydrochloric, sulfuric, nitric, fully ionizes. Every molecule donates a hydrogen ion. A weak acid, such as ethanoic, citric, and carbonic, only partially ionize. Most molecules stay whole. In the exam, if the pH stays high, even at high concentration, then the acid is weak. If a dilute acid gives a very low pH, the acid is strong. Use the words fully ionized or partially ionized in your answer. Think of it like this: strong acids let go and weak acids hold on. pH and hydrogen ion concentration. The pH scale is logarithmic. As pH decreases by 1, hydrogen ion concentration goes up by a factor of 10. So pH 1 has 10 times more hydrogen ions than pH 2. pH 1 has 100 times more than pH 3. In the exam, if asked what happens to hydrogen ion concentration when pH drops from 4 to 2, the answer is 100 times bigger. 2 factor of 10 steps are stacked. So each pH step is a factor of 10, 3 steps down, 1,000 times more H+. Half equations in electrolysis. Now the trap is balancing the electrons. Students write the equation and they forget the electrons and therefore lose the mark. So the pattern is that at the cathode, positive ions gain electrons. Electrons go on the left of the arrow. At the anode, negative ions lose electrons, and electrons go on the right of the arrow. So in this example, copper ions are gaining at the cathode. Copper 2 plus 2 electrons gives you copper. Chloride ions are losing at the anode. 2 chloride ions gives chlorine gas plus 2 electrons. In the exam, balance both the charges and the atoms. Count the electrons on each side. They must equal the change in oxidation state. And if you remember oil rig, oxidation is loss, reduction is gain of electrons. Cathode is reduction, anode is oxidation. Bond energy calculations. Bond energy is a 2-step sum. Step 1. Add up the energy needed to break every bond on the reactant side first of all. That number is positive. Step 2. Add up the energy released when every bond forms on the product side. And that number is negative because energy is released. Total energy change equals bonds broken minus bonds formed. Negative answer means exothermic, and a positive answer means it's endothermic. In the exam, draw out every bond, not just the formula. Hydrogen has 1 bond, oxygen in water has 2 bonds, methane has 4 bonds, and count them. Don't estimate. Concentration in moles per decimeter cubed. It's the same formula as grams per decimeter cubed, but just with moles. Concentration equals moles divided by volume in decimeters cubed. If you have grams, convert them to moles first by dividing by the relative formula mass. If you have centimeters cubed, divide by 1,000 to get decimeters cubed. Then plug that into the formula. In the exam, make sure you watch the units. The most common mistake is forgetting to convert centimeters cubed to decimeters cubed. There's 1 mark for that conversion alone, so don't lose it. So to remember, moles over volume, and convert centimeters cubed to decimeters cubed first.